Okay.
Yeah, yeah, we all good.
Any audio in here?
No.
No?
Yeah, just slides. Thanks so much. And, yeah. How's the vibe, friends? Good, good community feel we got going? I feel like I left my, oh, here we are. I just want to make sure that I have a timer. And here, there we are. Pop that. Cool. All right, well, yeah, my name is Leigh. Thanks everyone for coming. I come from the Kubernetes and Flux communities. I know I'm not the only Filipino person at this conference, which is always nice. Sometimes that happens. So I think, it's really important that we stay connected with our culture, right? And it's really cool being in Toronto because we have people from all sorts of places here. But yeah, if you like snowboarding or are Filipino or come from Colorado or are just a GitOps nerd, we should all hang out and chat. My friend Peter gave me this sticker here. I'm rocking the new Sigboba logo right here. So I want to talk about something that's probably nostalgic and painful for all of us. Who here is an infrastructure person, practitioner, right? You spend time at the command line. We probably have like devs and other stuff in the house, right? But this is the nostalgic problem that infrastructure people deal with, right? Who loves talking about configuring DNS? It's like your favorite activity, right? You just came out of stand-up, you're looking at the backlog. Yo, we need a new host name. We got a new host name for our app, right? coolapp.company.com. We got the DNS thing that got to point to our edge servers. And then the edge servers got to go point to the backends. And so the way that we used to kind of do this is like, we got to take the IP addresses of the edge servers. We're going to take that information from one system. Remember systems thinking? We're going to be moving it over into another system. Right? We have an output and an input. Output, the IP addresses from the edge servers go into the awesome web page for my DNS provider that we pay money to, and we're gonna make the cool name for our load balancers. Now, our load balancers are our own system of themselves, right? We run those things because they're really good at tracking a bunch of connections from all around the world. We have them in a bunch of different places. And so they have all of these different addresses, but my cool app is not the only thing that those load balancers got to move traffic for. So it's important that they know what the name maps up to in the backends. So we have this very painful problem that shows up again. Now we also got to take the name that we put in the DNS records and we got to actually configure it in the Ruby template that feeds our edge servers. And there's more pain. Right? These systems are literally codependent on each other. They got different configuration technologies. One of them, I'm like in a Puppet repository, modifying Ruby templates for an Nginx config, which is this like bespoke language. And then on the other end of things, I'm taking IP addresses from some infrastructure system and I'm logging into a web page. Fun, right? Now, the other fun part about this is that the edge servers are also codependent on the IP addresses of the backends. And now we want new backends. We're trying to do an A/B deploy, right? So we spin up our servers, we make sure they're ready, logging in, do some pre-validations, and now we want to start shifting traffic. So we got to go update more configs. It's like problem after problem after problem. Anybody relating to this, right? We're just always gluing stuff together. And you're like, okay, well, I need some robots. Why don't I go and make a robot to go update the DNS config? It's going to go and just grab the IPs, and it's going to go and put them into the DNS provider's API. We got to click some stuff around in the web console still, but for the most part, if we want to add a new edge server, I can just run the script. Cool, I got a bespoke robot for that. Maybe I also need a robot that handles all of the service discovery stuff. Then I can actually do A/B deploys repeatedly. That seems like a good thing to do. And so we used to do this thing kind of all the time. I know some of y'all in the audience like, Leigh, why are you saying used to? I just did this 2 days ago. Fair? At some point, I work with this person named Jim, and Jim is the person who actually pays our DNS provider. You know, as the CTO, he's kind of got a bunch of responsibilities, and he's like, hey, every time you run that script, I need to know about it. Could you open a Jira ticket every time you do that? So today, if you want to solve this problem with new open interfaces in a fancy hermetic box, you can use Kubernetes, right? Kubernetes got the service discovery part underneath, right? It's going to manage a bunch of different computers. It owns some networking pieces. And then you can install this add-on called external DNS. And external DNS is this kind of open source robot, right? It's not a special purpose bespoke script that does one thing for one provider. It has the same interface. Everybody kind of works on it, and pretty much no matter who your provider is, you can go and use this robot to repeatedly solve this problem for you. Great. Kubernetes is this fast, consistent, distributed computer. It has a unique programming model. It's got unprecedented capabilities. If you ever looked at the CNCF landscape, it looks like a hell of icons. That's because we got a bunch of different special purpose computers and open source interfaces that we're all working on. We're in a good place as practitioners, right? We can pick up some tools now that sort of have a good shape, so we're not always cutting ourselves on bash scripts. Kubernetes has got like promise theory, consistent APIs and stuff. When you use this computer, it gives you a way to talk. It splits up its APIs into a bunch of cool capabilities, right? You want to deploy apps, you want to set up networks, you want to manage lots of different computers. It's got an API for that. Enforcing policies, all of these APIs split up the computer into different resources that we can use. So cool, everybody wants to use the computer. Everybody. Right? We have this thing, we plugged in 100 computers into it. Maybe your data center is a little bit bigger than that and you're testing the limits of Kubernetes at 2,000 nodes per control plane or whatever. You're not the only person who wants to use the computer, right? Because there's lots of different things you can do. Right? Some people only ever deploy apps in their life, and some people are only ever focused on enforcing policies. And so sharing the computer feels a little bit not so tool focused, right? Now we're in a world of people and process. You know, we used to always say in the DevOps movement, people, process, tools. People, process, tools. And if we know each other, you probably know how fanatic I am about GitOps. GitOps is something that really excites me. Right? Last week I was just at GitOps Con in Vancouver, you know, appreciating some of that Canadian politeness, right? So I'm glad to be here in Toronto again, talking about GitOps. Now, if you look at the Open GitOps project website, it says that there are 4 principles. And it's like, this is what a GitOps tool should do. Right? It should have a source of truth. It should be always pulling that source of truth into the system with software agents and all of this other stuff. It talks so much about the tool, what the tool should do. We are in a dangerous place as a practitioner community where the adoption of our tools is hockey sticking up into the sky. Right? Everybody wants to do something new with these new interfaces because these tools make our lives easier. Right? We no longer have to be in this fresh hell with the Jira tickets because we can do stuff like this. We don't have to rewrite our solutions because we can share them and we can even bring them with us when we go get a new job. Y'all know that happens like every 2-3 years sometimes, right? So Kubernetes gives us this way to talk, to split up APIs, to share the computer. But all of that sharing, it is begging for a name. You see, the GitOps is the talking to each other. It's the using the Kubernetes to do that verb of collaborating with all of these people, right? Now, Kubernetes itself is not a forum. It's not a collab tool. Ain't nobody logging into Kubernetes trying to talk to Sarah, right? I'm not like, Kubehuddle, let my manager know I'm about to release. It's not a version control system. Kubernetes doesn't care what the state of things was yesterday. It doesn't care about your comments. It doesn't care about your field orders. All it knows is what the truth is of the desired state of the system. So we need something else if we want to do the GitOps, if we want to collaborate, right? So we want to bring that programming model, the promise theory, the consistency of the etcd value store behind the scenes, right? The fancy distributed computer, we want to bring that into our place of collaboration. That's why I'm excited, right? That's why I'm excited. I'm excited, and we get into our organization into a place that looks a little bit like this, with big clusters and small clusters all around. Some of them are running in US East, and maybe those ones are running under the desk of some development team who wasn't, enfranchised to get the budget to run their new software, but they're super smart. I know that's been me. Why are we looking like this again? With bespoke robots in between systems, Jira tickets, silos. We got some lessons from the past 10 years of doing DevOps with each other that we gotta make sure to not forget. So, software delivery performance. Software delivery performance, how do we know that what we are doing, that we're doing it in a good way? At the end of the day, we all try to ship software and to do it in a way that feels like we're being able to change the system quickly, which is the nature of our jobs, that we are able to decide how to change a system, and that we do it in a way that doesn't blow up in everybody's face all the time, right? And these are things that we can actually measure. There are 5 DORA metrics. DORA is the DevOps Research Association. Recently enough, it was acquired by Google, but they still do great work. It's just now that Google gets to use them to make lots of money with the customers. But they still run the Dora.dev website and all of that. The story of Dora is that in 2014, we as a DevOps community were starving for data about whether or not we were doing things in a good way that actually made a difference. And so we went out, surveyed like 2,000 companies, and we're like, hey, look, these are the indicators, if we do actual statistics, that show that people can perform well in organizations or people can perform badly. The high performers do well in these 4 areas, now 5. Right? In 2021, we added reliability. So let's go through them. Deployment frequency. We want to make sure that deploying to production, actually getting your software, making a change, putting it live and getting in front of users, that we can do that very, very quickly, that we can do it almost second nature, right? Ship the change. We want to also make sure that when we actually decide to make a change, when we come up with an idea, when we have a hypothesis that says, hey, I want to change the way that these fields work. I want to split up this data so we can capture some new metrics. I want to create a new experience for your user. I want to give them the ability to add some data and control a different part of their life using our software. That we can do this quickly. And so that means that as ideas come into generation, go down the product line or whatever, we talk to people about how we can make this change, that we want to keep that lead time kind of low so that we can actually validate that our change is atomic and that we have like a good result from it, right? So we want to do these things quickly, make it second nature to deploy, and we want low lead time. We also want to make sure that when stuff goes wrong, that we're able to quickly restore service. You would think, oh, gosh, that seems nice. Well, then how come your escalation process requires 3 calls and it breaks down in the middle of the night and you got a totally separate process? How come you got this incident now that's been rolling for 42 hours? Time to restore service, this is important. High delivering software organizations are able to deploy quickly, have low lead times, restore service quickly, and keep a low change failure rate. Now, we added this one in 2021. This is a new metric, and reliability, this one's interesting because it's only important, we only see it show up in high-performing organizations when they're already good at the other 4. So it doesn't pay to be reliable if you can't already deploy frequently with low lead times, restore your services quickly, and have low change failure rate. Now, how does that apply to GitOps and Kubernetes then? right? Where does this show up? How can we make sure that we don't forget the lessons of the past 10 years as we pick up these new tools, building new systems for the future? Well, I would like to really point out a guiding principle here when we are changing infrastructure systems, build systems, we're doing new deployments, we're trying to inject new validation and process into the way that we work with each other. Please remember to decouple integration, delivery, and deployment. Right? We always hear in our heads CI/CD. It's honestly like a kind of a bad acronym because it makes people feel like it should be one thing. But these are not one thing. Continuous testing and continuous delivery, they're very different things. GitOps really helps with delivery and deployment. But it doesn't really do the testing and integration part necessarily, right? Until you bring maybe some of those systems into some continuous process loops or whatever, then maybe you can GitOpsify it. It doesn't matter. Anyway, at the end of the day, you need to keep this stuff decoupled, which means that you should be able to do these things separately from each other. Some people, this is just like one script, and it's only accessible inside of Circle CI. You need to be able to test, release, deploy separately. So when you decouple these kinds of things, you might find that your ability to restore service is actually a lot easier. Right? Because now your delivery of the release is separated from your ability to deploy that release. Right? These things are not tightly coupled together in some pipeline. Similarly, if you need to be able to cut a release, but you have to skip some test phases, say you're in an emergency break fix scenario, you already know that you can release a bunch of things separately, you can deploy them separately, so if you need to skip that test phase, you have this decoupled away from your release pipeline. You don't have to run 4 hours of tests to try and get a change to production. If your pipeline is decoupled, it will take care of you. Maybe you don't need to mandate that every piece of software goes to a stage environment for every single change. So if we go back to deployment frequency, the reason why people find a lot of success with deploy frequency is that it actually tends to also be in this very coupled system with change failure rate. Why is that? Well, say you do something like this. Every time somebody wants to make a change, their stuff is going to get deployed to stage. Sounds like a good process, right? Well, if your deployment systems have so little safety that you are going to require everybody to pretend like they're going to production every single time before they actually get to the real place where their change can be validated, what you're actually doing is injecting cycle time. You're injecting a mandatory weight into every single change, no matter what size it is. What do you think that that does for somebody who wants to make a small change? And what you see then is as you make the path to production longer, batch sizes of code changes tend to increase. With batch size comes risk. With larger changes becomes the more of the unexpected interactions. Now you're changing not just one baby thing, you're changing 2 or 3 slightly bigger things, all at the same time. That makes changes risky. So if your environment looks like this, where every time you want to ship, you have to go to stage, maybe take a step back. Think, what is that doing for my deployment frequency? Is this also affecting my lead time? Because now we have multiple things in the pipe, our batch size is up, and so we're not just working on one feature, we're working on 3. Does that prevent us from keeping a full mental model of the system? These are lessons learned from, again, nothing new. This is not about GitOps. This is not about API machinery. This is not related to Kubernetes. We've known this stuff now for coming on to 10 years. So just some stuff to consider. Also, deploy frequency and change failure rate, they're quite related, right, because of batch size. So here, sort of at the end of all of this ranting, right, we have a recognition that if we're going to be getting into these cloud-native tool sets, working with each other on a distributed computer, right, which I think is like, looks like this, right? Everybody wants to share the computer. They want to do all of the things that our tools are going to really shape the kinds of organizational habits that we have with each other. Right? And so if we want to do the GitOps, we need to remember that it's not just that the software agents are going to go look at the source of truth to continuously bring the changes into the desired state of the system. Right? That's what the tool does. What is the habit that that tool is asking of us? Kubernetes is begging for GitOps. What is GitOps begging of us? Well, Kubernetes is this computer. And the only thing that it fundamentally is good at is making promises for us. But GitOps is about making promises to each other. Right? So, yeah, my name is Leigh. Let's chat. Right? I have plenty of time for questions as well, I think, or well, I should. But yeah, thanks, friends. Okay. Does anyone have any questions or a story that they wanted to talk about? Cool. Sweet. Well, I will be around and we can chat more. I think we'll have plenty of time as well for the next person to come on deck. So hit me up. That's my Twitter and GitHub.
Awesome. Yeah. Great talk.
Thanks, Rishab. Here we go. Get that love back to you. And here we are. I have made a mess here. I'm just gonna unplug this. There we are. Here's this. And then this is here.
Thank you.
There we are.
Good.
Oh man, here. And this is Marino's.
So, stop the video.